Hello everyone, today we'll do transportation problems in LPP. The transportation problem is one of the subclasses of LPP in which the objective is to transport various quantities of a single homogeneous commodity that are initially sorted at various origins to the destination. That is, if these are the origins and these are the destination, we are transporting. To various origins to different destinations in such a way that the total transportation cost is minimum. That is, the cost of sending this item to there, this item to there, this item to there is minimum. Students, before we continue, we should know few things. They are, firstly, feasible solution. What is a feasible solution? A set of non-negative values xij where I is equal to 1, 2, 3, 4 till m and j is equal to 1, 2, 3, 4 till n that satisfies the constraints is called a feasible solution. That is, xij must be greater than or equal to 0. What is a basic feasible solution? Or BFS. A feasible solution that contains not more than m plus n minus 1 non-negative allocations is called a basic feasible solution to the transportation problem. Now we move on to the optimal solution. A feasible solution, not necessarily basic, minded students, it might not be basic, is said to be optimal if it minimizes the total transportation cost. Hence here the minimization is the maximum. We get the least transportation cost in a optimal solution. Now students, let's move on to the first type sum, that is northwest corner rule. Northwest corner rule. Step 1. Starting with a cell, the upper left, that is the northwest corner of the matrix, we allocate as much as possible so that either the capacity of the first row is exhausted or the destination requirement of the first column is exhausted. That is, in step 1, x11 is equal to min of ai a1 b1. In step 2, if b1 is greater than a1, we move vertically to the second row and make the second allocation of magnitude x21 is equal to minimum of a2 and b1 minus x11 in cell. Else, if b1 is less than a1, we move right horizontally to the second column and make the second allocation of the magnitude x12 is equal to minimum of a1 minus x11 b2. If b1 is equal to a1, there is a tie for second allocation. You can make the second allocation of magnitude at x12 is equal to or x21 and allocate minimum of a2 or b1 minus b1 which is equal to 0 into the cell. Now the step 3, repeat the steps 1 and 2 moving downwards to the lower right corner of the table until all the requirements are satisfied. Until all the requirements are satisfied. This is step number 1, this is step number 2, and this is step number 3. Now students, let us do a problem. The problem says a dairy farm has 3 farms located throughout a state. Daily milk production of each plant is as follows. Plant 1 produces 3 million liters, plant 2 12 million liters, plant 3 8 million liters. Each day the firm must fulfill the needs of its 4 distribution centers. Minimum requirement of each center is as follows. Center 1 is 7 million liters, Center 2 5 million liters, Center 3 9 million liters, and Center 4 2 million liters. Now let us represent it in a demand and supply table. Now the supplies are as 3, 12 and 8, and the demands are 7, 5, 9 and 2 by the problem. Now by the northwest corner rule, we find the northwest element, that is 2, the cell 1, 1, and we try to allot. Let me write, this is demand, this is supply. Here the demand is of 7, but supply is only 3. Hence we allocate the minimum, that is 3. And we see that the first row is fulfilled. Hence we move on to the first cell of the second column. Here the supply is 12 and the demand, which becomes 7 minus 3, that is 4. Hence we allocate this as 4 and we see that this column is satisfied. Hence we move on to the right of the previously allocated cell, that is this cell. Here the demand is of 5 units, whereas supply is of 12 minus 4, 8. Hence we allocate the minimum, that is 5. Clearly this column is also fulfilled. Hence we move on to the right of the previous column, that is this column. Here the demand is 9 but the supply is only 3, as 8 minus 5 is equal to 3. Hence the minimum of 9 and 3 is 3 and we allocate this. Similarly proceeding, we see that the allocations are as the following. Now we find the total cost. Total transportation cost. This is equal to 2 into 3, that is the base and the allocated number. Base into the allocated number plus base into the allocated number, that is 12 into 4, plus base into allocated number 10 into 5. Similarly 6 into 3 plus 50 into 6 plus 9 into 2, which is equal to 230, and converting we get rupees 2300,000. Sorry, I put 1 0 extra. It will be rupees 2,30,000. This is the answer.